Good morning, guys. So yesterday we talked about domain and range, and today I just want to start by going over some of the questions that gave you a hard time. I'm going to start with this number 18. Number 18 was asking you to find that domain and range. Remember, domain is all x values that exist on that function, and range is all the y values. When you look at this function, since it has that arrow and that arrow, it shows that the function continues endlessly in both directions. Endlessly means this goes all on the x-axis. This will go all the way towards negative infinity as it keeps going that way. And this one will also go all the way because it's going to continue that way, and that one's going to continue that way. So, and same thing, upwards it goes all the way, and downwards it goes all the way. So if I want to write the domain and range of that function, give me a sec. I want to write the domain, come here, here. Domain and range of that function, since it's like this, kind of looks like that. I know that the domain are all the x values, so I can say that its domain starts from negative infinity, goes all the way up to positive infinity. I can also write this as domain equals, or domain is, x is a member of all real numbers. I know you may have seen this on the answer sheet and it was confusing you, but that's simply what it means, that the x values are all the real numbers that exist on the number line. This means is a member of, this is the symbol for real numbers, and this is just the x. The range will be the same thing, because for this graph, the range, same thing, starts from negative infinity and goes all the way to positive infinity. The y values go from negative infinity to positive infinity. Or I can write it as range is y is a member of all real numbers. Let's look at number which one? Oops. Number 19. Number 19 is a little bit different because it only starts at 0. It starts right here at 0. On the x-axis it continues forever because of this arrow, and on the y-axis it also continues forever because of that arrow. So its domain will be x starting at 0 all the way up to infinity. X starts at 0 up to infinity. That's its domain. Or I can write it as in set notation. I can write domain is x is a member of all real numbers, and x is also greater or equal to 0. Those would be the two correct conditions for the domain. The range, same thing. Range, I can say y starts at 0 because it starts here at 0 and then goes all the way up. It starts at 0 and then goes all the way up to positive infinity. Or I can also say the same thing here as I did, just this. I can say this same thing and this same thing for the range. I can say range is that y is a member of all real numbers, and also y is greater or equal to 0. So that would be domain and range. Number 20 and 21, those ones, it will be easier if you actually put them on a graph. If I went to Desmos.com, yeah. If I went to Desmos and what is my thing? Desmos calculator. Yeah, if I went to desmos.com/calculator and I wrote in the equations for number 18, number 20, if you can see it from there, it's y equals x squared minus 3. So if I wrote it in there, y equals x squared minus 3, and you look at that curve, that curve, here something I can do is to apply the vertical line test. So let me just put any vertical line. If I put any vertical line, I can see that the vertical line cuts the curve only once. Since it cuts the curve only once, it won't cut it again. No matter how high I go, it won't cut it again. Since it cuts it only once, that's enough to tell me that it's a function. So that's how I know that number 20 is a function. 21 was magnitude of x minus 4. Now remember, magnitude simply means only the positive values, or consider the positive values only. So magnitude of x minus 4, that's what it looks like. The graph looks like this. X minus 4 magnitude, that's what the graph looks like. So that's what it looks like. X minus 4. It's not really a curve, it's just some kind of V shape that goes upwards like that. And just like the previous one, if I use the vertical line test, something like x equals negative 3, if I use the vertical line test, what is this? X equals 3. If I use the vertical line test, you can see that it cuts the curve only at one point. So that is also enough to prove to me that it's a function. Challenge problems. Is the graph graphed below a function? How can you tell whether this is a function? Again, I'm going to use the vertical line test. How? If I draw a vertical line here, right there, straight going through both those circles, this vertical line cuts the curve only once, because this point here is included, but this point is not included. So technically, this line doesn't cut the graph here. If I draw another one here, same thing. This point is included, but this one isn't. So it doesn't cut the graph at this point right here. It doesn't cut it. If I draw another line here, vertical line, same thing. Here it cuts it, but over there it doesn't. So since there is no case where a vertical line cuts this curve twice or more than once, I can conclude that the vertical line test has been satisfied, and therefore this is a function. Alright, is a person's weight a function of their height? Why? Weight, not necessarily, because you can have two people that have the same weight or have the same height but different weights, or same weight but different heights. Does that make sense? You can have Trevor and Hudson maybe having the same weight but different heights. So their input, which is the weight, would be the same, but their output, which is the height, would be different. And you know that if you have two inputs that have different outputs, that's not a function. So not necessarily. It's not necessarily true all the time that a person's weight is a function of their height. Is the height of a rocket a function of time? This one, yes, because as a rocket goes up, at any point along its motion, it will have a particular time, t1, t2, t3, t4, etc. And at each point along that, at each time, along its path, it has a specific height. It can't have the same height value at two different times. It's just practically impossible. The last one, James says that since y is the magnitude of x is a function, then x magnitude of y is a function. Is he correct? Same idea here. You can go and graph these things on Desmos. Graph this on Desmos, and the other one over there on Desmos, this one, and then use the vertical line test to check whether it's a function. So today we're going to do more practice with range, and we're going to do more practice with domain and range. So take a look at those worksheets and try them out. All right, bye.